Welcome to Easy Mathematics and a new video to the MIT Integration Bee 2020. This is problem 1 from the final round, and the integral is following. Evaluate the integral from 0 to pi over 2 cosine x times inverse sine of cosine x dx. And as a hint, if you think about substitution, I do not know if there is a suitable substitution. There is 2 times the cosine, so if we substitute a cosine, then it becomes a sine or minus sine, so it would be more nice if this would be cancelled out. So I would not think about the substitution. I would think about integration by parts, and as a second hint, keep the sine function in your mind. And just to recall, what is the sine function? The sine function, it returns the sine, so it's plus 1 for positive x, minus 1 for negative x, and 0 for x equals 0. And there is a second expression for the sine function, like a second definition if you like, or you can define it like here piecewise, or you can define it maybe a little bit more compact, and this is following: x over absolute value of x. So let's tackle this integral with integration by parts. So I choose u prime, the cosine, and v, the inverse sine part. U prime equals cosine. This makes u sine of x, and v is the inverse sine, so the derivative of the inverse sine is 1 over square root 1 minus x squared. So this becomes, in the first moment, 1 over 1 minus cosine squared of x square root, and then with the chain rule, the derivative of the cosine is minus sine. Okay. This looks not so beautiful, but if you think about 1 minus cosine squared, this is a sine squared, and with the square root, this becomes minus sine over absolute value of sine. And just seconds ago, x over absolute value x is the sine of x. So here we have minus sine of sine x, and this becomes more beautiful if we consider our interval from 0 to pi over 2. This makes v prime minus 1, because x is in the range of 2 to pi over 2, and the sign is there positive, so sine of x in this range is 1, and there is a minus, so v prime is minus 1. How beautiful is that? This is very, very, very helpful. So integral u prime v is uv minus integral uv prime, integration by parts. We have all 4 functions, or all 4 parts we need. So u times v is sine times arcsine cosine of x in the range of 0 to pi over 2, minus the integral of from 0 to pi over 2 uv prime, u sine x, and v prime is minus 1. Very nice. And you can check easily that the first part becomes 0, and the second part is very easy. This becomes 1, and therefore our final answer to this integral is 1. I hope you liked it. See you next time. Bye bye.